thank you guys. Thanks for having us. We've been on a bit of a tour doing this at different trade shows, different speaking events, Becker's and Class and others, HFMA here recently, and it was for Aspirion being a provider-centric organization focused on the revenue cycle and specifically complex claims, high-dollar complex clinical denials is where we spend our time as a tech-enabled services company. We took it upon ourselves in the past 2 years to seriously invest in, can we automate? How much of this stuff can we automate? And throughout that journey, we've been sharing our progress at these different events. And Spencer and myself, working on it day in and day out, we've learned a lot of lessons. And so we feel like it's our duty as partners to provide organizations to share what we've learned along the way. And so this is just another one of those kind of milestone touch points where we're hopeful we can share information, some lessons learned along the way, and missteps and other that we've encountered as we've been on this journey. So that's the intent of the presentation. We'll walk you through kind of how we've stepped through everything from acquiring a business that does this to the various use cases we've had, some of the success we've had early on, and kind of where we're going with it. As Alan said, Alan and I used to work together, so it's nice to see him. I am the Chief Strategy Officer at Aspirion, been here about 18 months. I've been 25 years in the healthcare tech and revenue cycle space. Early on, Ernst & Young and Deloitte, turnarounds for health systems, implementation of Epic at Kaiser, those kind of things. And then I spent 8 total years at TransUnion in their healthcare division running product and strategy, M&A, and our go-to-market teams. Split in there was Conifer and a stint at Ciox. And then again, I joined Aspirion, where I've got responsibility for our overall technology and product strategy underlying the business, working a lot with Spencer and our AI and innovation teams. I've got responsibility for our M&A and our broader strategy functions. Spencer?
Yep. Hey, everyone. Spencer Alley, Chief AI Officer at Aspirion. Joined almost 2 years ago, January of 23. I'm responsible for our innovation and AI functions. Within that, product technology, data science, all centered on how we use machine learning and artificial intelligence to accelerate the work we do and drive better outcomes for our clients. My background has always been at the intersection of machine learning, innovation, and then real business problems, particularly in B2B regulated spaces. So prior to healthcare, I led technology, machine learning, and product at a regulatory compliance technology company for about 5 years. A few other roles, started at PwC leading their AI labs for about 4 years after some consulting work. So it's been a fun journey. I'm excited to talk about it.
So this is nothing you guys don't know, but as we are looking at the market with, 180 clients, provider clients across the United States, some part of the work we do was historically in the complex claims space, so motor vehicle accidents, workers' comp, out-of-state Medicaid, VA TRICARE. But the majority of our business has been focused on third-party follow-up and denials. And in particular, we've got 180 attorneys that are known for crafting arguments to overturn high-dollar complex clinical denials that require clinical validation. So they require us to pull the medical record, compare it against the denial reason code, generate an argument related to the care guidelines and payer policies along with the coding guidelines, and then craft that argument back to the payer to say why we should be paid at a certain rate or paid at all. It was medically necessary. And so what we're seeing in the market, what we're particularly seeing in the market is massive increase in denials, mostly associated with the implementation of technology by the payers, given their consolidation, their bigger capital budgets than the provider market has. And they're pushing for payment integrity type of initiatives where they can use technology to quickly screen and identify outliers for certain case types to control spend to reduce the amount of reimbursement back to the health systems. And while the growth in overall denials and volume, roughly 12% across the nation, it's the particular type of denial that's troubling as we're looking at it. So it's not your normal, I messed up the registration, not the right carrier, right, not my member, kind of administrative type of denial. Those are still there. We still make errors in the revenue cycle. We got it, turnover, and all the things that cause those problems. It is the clinical denials that are not even full clinical denials, but rather downgrades. So be it a patient type downgrade, a DRG downgrade, where they're saying, I'm not going to pay you. I paid you $10,000, but then I reviewed it and I took it back and then I paid you $8,000. And so it's this death by 1,000 cuts where these smaller dollar, lower balance denials that we can't otherwise, from a unit economics perspective, put a human on, because it still takes the same amount of work. Right? It still takes a certified coder or a nurse to review a medical record to craft a clinical argument against care guidelines, just as if they would have denied the full 10,000. Well, full 10,000, yeah, I can go after that. The Delta 2,000, I can't afford to do that because the volume is high and the amount of work is still the same. So for us as an organization, we have that same problem, right? I can't put attorneys on it, I can't put coders on it, I can't put nurses on it. I could and charge an 80% contingency rate, but nobody's paying that. And so our journey was more about how do we deploy technology to help create that same argument that uses those same referential guides, so payer policies, care guidelines, Milliman, Interqual, or coding guidelines, compare it against the clinical documentation itself, and write a compelling argument why we should be paid a certain rate. So that's the journey we've been on. We did that. We went through. We have been on a similar journey, and I would say the advent of the technology as it's advanced in the last couple of years, specifically with large language models, has changed the dynamic. So the things we used to not be able to do to take unstructured data, structure it, and create a logical argument, we can now do. And so we have been on this journey, again, to figure out, do we build it, do we buy it, do we partner, what do we do? And so along that journey, we first needed to identify the use case where we were going to deploy it, which I just mentioned. How do we write a compelling appeal letter based on clinical guidelines? Do we have the data necessary and the access to the data to do it? Yes, I've got plenty of data coming in from plenty of clients to do that. Do we have a platform? Our answer was no. We did not at the time. And do we have talent? And talent can come in two buckets. Talent can come in the bucket of PhD, data science, and technologists to engineer the platform, but it's also talent around change management, product management. It's the subject matter experts that do this thing in a manual way today. Do we have access to that talent? And for us, that was yes. And so we then in the fall had done, last fall, had decided to acquire a business. We'd started off with 3 pilot programs using 3 different organizations. We had a couple of PhD data scientists internal to us that Spencer had hired and started a team. And we were testing what are the capabilities of some of these other companies that are earlier stage. And what we found was a company called Infinia ML, which we acquired last fall, was a company that had been around for 5 years, had started as a startup out of Duke University. It was 5 PhD data scientists, a handful of machine learning engineers, all with master's degrees out of Duke. They had gone on a journey to build a technology platform and then apply it to multiple different industries. Healthcare was one, life sciences, they had gone property and casualty insurance, they had looked at law firms, they had done work for all of them. They all have unstructured data between 2 parties, and they were using their platform they were building to structure it in large language models. We did a pilot with them. Again, we said, this is the use case we're trying to solve. Show us that you can solve it. And they started to and did. We had great success. We acquired that business. So we kind of went through this whole, should we build it, should we buy it, should we partner? We bought it. That team, I can happily say, is now 38 people, including a half a dozen, basically, PhD data scientists and a number of machine learning engineers. And They are focused solely on our use case of automating these functions of crafting an appeal letter. Again, we're not licensing the software. It is merely to make our world more efficient and to do a better job and a higher quality outcome for our clients in a contingency basis today. And so that's setting the stage for how did we go about it? What are we attempting to do? And then I'm going to let Spencer kind of walk you through the very specifics, including showing you exactly what these tools look like, what they do. These are not theoretical. There's a lot of theory of what it could do, what it might do. No, this is in production today, being used by our folks today to process clinical denials. So Spencer?
Yep. So as Jim mentioned, when I first started, we did not have an AI team. We had a technology team, but it was mostly focused on legacy technology. So the first step was, how do we actually kind of get started on this AI journey? And what I've learned in all my roles leading up to this is you want to start with some simple use cases, simple pilots. You don't want to overcomplicate it at the beginning. You want to just start getting some points on the board in terms of, hey, here are some easy things that do start to work. So we're going to walk through some of those. We started with selection models, which is basically estimating the value of a claim and the likelihood of it getting overturned if it's a denial, and then using that to help prioritize work queues and so on. We're going to show kind of more detail on that and how that works. But then once you can start to demonstrate impact with some of those early pilots, then moving into kind of a broader roadmap and program. And that's where we get to the more complex use cases like appeal letter generation for denials and pricing models and other things. So it was kind of a crawl, walk, run approach, so to speak. And now we're very much in the run stage, which is a fun place to be.
Yeah, I would add, as you talk about it too, one of the things we found as we looked at Infinia as a business to acquire was they had struggled over 5 years. Like, they'd done a great job of building this platform that they have. We call it DocIQ, which we'll get into. But it was a technology built purposefully for taking unstructured data, structuring it, and producing some kind of generative output. Didn't matter what industry it was. They were basically a technology looking at, can they solve different problems for different industries? And what was highlighted to me is, like, they had great technology and a great set of individuals that have like amazing backgrounds in data science. What they weren't given as an outsider with a technology was access to data. Like, it's a project, you're a client, we're their client, but it's a project, we'll get to it kind of thing. We'll give it to them, piece by piece, which we all know in healthcare, we've got stacks of people in line to get data, in our IT departments. They had that same challenge across all of those industries. And then in addition, they had the challenge for time and, again, education or focus on this is how the process works today in a very manual way, so that they could figure out where in that process can I automate. Well, when we brought the two together, what we had was, all these people doing it in a manual way, and I had plenty of data. We didn't have the platform and or the technologists to automate it. And so bringing the two together for us unlocked a bunch of opportunities for both organizations, quite frankly. And so we'll go through kind of what those look like.
Yep. So I'm not going to go into too much technical detail here, but what you're seeing is a diagram of the actual platform component of this, use case data talent platform. So we have a core workflow system that we've built that Aspirion had already built internally called Compass. And then as Jim mentioned, with the Infinia acquisition, we brought in the platform we call DocIQ, which is the AI platform that runs in parallel to our core workflow platform. And we're doing a number of different things behind the scenes to actually meet these use cases where we need to with the right technology that we need to. So we're going to talk about scoring models, about AI assistance, about appeal letter generation, and more of a full automation kind of approach. But we do everything from host our own models, use some of the commercially available large language models, fine-tune some of those for healthcare-specific use cases, And then, all this is kind of embedded in this platform that we develop and maintain as we expand to more and more use cases. So I guess part of the message here is this is not as simple as just going to ChatGPT and saying, hey, write an appeal letter for me, right? That doesn't work. It might work on a one-off basis, but it's not scalable and it's not accurate, especially for complex clinical denials, which are the ones that we really focus on. There's a lot going on behind the scenes here that we've built, and that's basically a necessary part of the kind of AI journey that any organization needs to go on. Again, whether they build it themselves or work with a partner that has built it, or buy a company that has built it. The other thing I would add before we get into the use cases is we start in particular with DRG downgrades is our first kind of use case around appeal letter generation. That's for a few reasons. One, as Jim mentioned earlier, it's a big growing problem for our clients in the industry. Two is it requires certain access to data. So you can have coding guidelines, medical records, denial letter. Those are information sources that we can now point large language models at and pull out the right information at the right time to be able to assemble the right argument for them. And then as we plug more information sources into this base system, so the clinical care guidelines, payer policies, other types of unstructured data, then we start to unlock more and more denial types, whether that's inpatient to outpatient downgrades or length of stay denials or other, as we kind of go through our portfolio. But this is kind of the visualization of the core system. So as I mentioned, our first use case where we started was kind of rewinding back, not touching large language models yet, but just using traditional machine learning scoring models to look at the cases we had and start to think about how can we work these cases more intelligently, right? How can we work the ones in the right order to maximize yield? How can we advise our people on the next best action, route the right case to the right desk based on what people are historically good at overturning? We started in one of our denial service lines. We trained on about 500,000 historical cases, and this basically looked at everything from CARC and RARC code, the underlying diagnosis and procedure codes, the history of the account, dollar value, all of those types of things to predict likelihood of overturning, and then the kind of expected value to our client of that, so that we could basically optimize our liquidation on that for our clients. On the screen here, you see kind of what I think of as a maturity curve for using these types of scoring models. So, historically, if you don't have any kind of prioritization, that's really the kind of naive baseline of, hey, just work them in the order that you get them, first in, first out kind of thing. You can do that, you'll get some liquidation, but it's not optimal. Then you start applying business rules that are more about, okay, let's put the ones at the highest dollar up front, but still no machine learning involved. Then when you get into these kind of 2, 3, 4, 5 areas, that's where you start to leverage AI and machine learning to really optimize the value you're getting from that. Those get more and more complex, but then there's more and more yield. So that was kind of the step one of our journey of just putting those models in place in certain service lines and clients to optimize the liquidation on those backlogs. Extending that to, as I mentioned, kind of full expected value is basically taking those probabilities, the balances, and then multiplying them to get an expected value. And then this, again, is just a smarter way to work, especially if you have limited resources and you have accounts that are timing out, and you don't have a lot of visibility into what you should work first. These models help you do that. So this just illustrates some of the results of that. So you can see basically the overall success rate for one of our clients that we applied these models to, as well as the high priority or the kind of high probability accounts. Excuse me. And what this illustrates is when we put the scoring model in place, basically what happened is we started to prioritize the right accounts. The model learned over time and got better. The probability of the high priority accounts then pulled up the overall probability of the total inventory for this client. And so you see the success rates climb and actually double over the course of a year, basically. So these are, again, kind of first use case, simple but powerful, just working the accounts more intelligently with the help of data and machine learning to inform how you do that. And that set the stage for more complex use cases that we'll jump to.
Yeah, when I joined Spencer, we had these well underway, and a number of data scientists already employed, hired into Aspirion proper and working on these models. And I was like, this is, being in RevCycle forever, it's like, this is nothing novel, right? These learning models of prioritizing accounts. If I got 100 accounts, but I can only work 60 in a day as a person, which 60 should I work first? It's good. I mean, it pulls, shortens your time to immediate results and does some of those things. And then as patterns change, we recognize those patterns quicker, and we can optimize for that and apply resources. But this wasn't a game-changing thing. But for us, and I think lesson was, look, it forced us to organize the data. You think you've got access to the data, and you start to look at the data as it being necessary in terms of a high fidelity type of data to feed a model. You quickly realize you got a bunch of garbage, and you're like, hey, I got to clean up a bunch of these things. So along that line, and he mentioned Compass, that's our just standard workflow distribution platform, takes in accounts, distributes them to the right desk work list for folks, and automates some of the functions along the way. You start to realize, though, that there's gaps in the data and some of the data you need. And so you start on this journey of, I want to feed this model, I want it to learn, I want it to be predictive, and you realize, well, there's holes in X client's data. They're not sending us these relevant elements that are very predictive around overturn rates for denials or liquidation of AR or whatever those cases may be. And so there are lessons learned around just going through this exercise of something as rudimentary as a prioritization model. And yeah, benefit from us doing a prioritization model. We increase, our overall liquidation rate for clients, better performance, that's great. Better understanding of the necessary resources, that's great. And seeing some of the patterns change within payer behavior, also great. So there's benefits along the way of at least starting down this road and figuring out where some of the gaps are and where some of the limiters are. But then we took a step forward and acquired the business, and the next use cases are really more of the true automation portion of what we started to do.
Yep, so first one was about prioritization, now we're talking about AI assistant. So this is still very much human in the loop. How do we help our people, our nurses, our clinicians, our attorneys, our operators do the same job that they're doing, but do it more effectively with help from tools? So in particular, one of the problems that our staff deals with every day is they have medical records that are hundreds or thousands of pages long, and they have to read through all those medical records to find the key information to support the appeal letter that they're writing. That in itself is just, it takes a lot of time. I mean, it takes a lot of time to read through that much content. In addition, they have to look at code set mapping. So if they're looking at a UB04 form and then having to parse and understand, okay, what does this revenue code mean? What does this diagnosis code mean? This procedure code? That's a lot of swivel chairing back to RevCycle Pro or Google or other tools to figure out what all that is and try to bring that together into a coherent argument. So then our first step along this kind of automation journey is, okay, let's give them an assistant that can read the UB04 forms, read the medical records, surface the most relevant information in a summary, and also give a kind of ChatGPT style chatbot where you can ask free-form questions, just, hey, what were the abnormal vitals for this patient? And then it'll just give you the answer and give you the citation. So we'll show here a short video just of the actual interface that we built. This is what you're seeing here is DocIQ. So first is kind of the UB form functionality. So what the tool does is it goes through and extracts every single code, every single text field. We have code sets mapped in the background, ICD-10, HCPCS, all the kind of Optum code sets. And then here's a sample medical record. You see predefined questions on the left and kind of these summaries that the clinicians ask every time they open a medical record. And then a free text field where you can ask whatever questions you want of the medical record, and it'll come out with answers with citation, so it brings you to the specific page where those are coming from. So these are really, again, very much tools for our people to use, human in the loop, but they're the building blocks towards the broader vision and what we're going to show next, which is really thinking more about end-to-end automation, still with kind of experts auditing and reviewing, but starting to actually do much more of the heavy lifting around appeal letter generation.
Yeah, I think on use case 2, what struck me as we kind of went along this thing is you've got to build these components to get to full automation, and some of those things are reference libraries, right? So I got to license code sets, and I got to map to code sets. I've got to train these large language models on the healthcare information and taxonomy and the language, right? I've got to be able to ingest up to we can ingest up to a 2,000-page medical record in under a minute, and ask it all of those questions that anybody human-wise, our lawyers or nurses, who's picking up a chart, who has a denial letter, says we denied it for this, downgraded it because we don't believe sepsis was there. How they know that off a freaking claim form is beyond me. But they basically put the onus back on us to say, prove it to me. So when one of our attorneys or nurses picks up this medical record of 2,000 pages, they consistently approach it in a similar way of, marking the sections effectively, asking it certain questions, finding certain evidence throughout. And so putting this together, we're pre-prepping that chart before they even see it, using technology to do it. So we're asking that series of questions you saw down the left. These are standard questions asked every time where evidence is pulled out. Also important to note for us is our team's using a RAG model. So it's a retrieval augmented generation model. It's it's an approach used such that we're not commingling this data with other data. Our platform is looking only in the 4 corners of that medical record. It can be up to 2,000 pages, but it's only asking the questions within that source data to get the answer. So it's not making up answers. It's not what they call hallucinating. It's not saying, I think it kind of looks like X. It literally, if it can't find an abnormal test result, it will say, I cannot find within this record an abnormal test result. If it finds abnormal test results, it will index them, and you saw those page numbers. You can click each one, and it'll jump you right to those abnormal test results where you've got evidence. So we haven't necessarily automated the process yet, but we've built the components necessary to bring the pieces together to allow for full automation. And the point in this is, in doing so, we sped up our nurse review by 30%. They could do 30% more in a single day just because basically I gave them a better version of Adobe Acrobat that was already pre-wired, right? They're not doing control find in a medical record. So just that, as you're, again, moving along the journey, is a benefit in that we can do now more in a day. We can do it more accurately because the machine itself can find all of the evidence within the record, versus a human is going to skip to certain points where they know they've made a case in the past, and they're going to kind of shortcut, especially if you're looking at a 2,000-page medical record. That allowed us to then get to this point, which Spencer.
Yep. So this is, to us, what was really the most exciting of our initial use cases, which is appeal letter generation, where you start with a medical record, a denial letter, and then the system itself does all of the looking at the right information sources, payer policies, clinical care guidelines, et cetera, to pull in and make the right argument, and then actually generate a letter that then our experts can read and review and make sure is accurate. But almost all of that heavy lifting has been done for them in the first place. So that's what we'll show here a demo of. But again, to Jim's point, all of the things that we've showed up to now help build up to this, and then the approach we're taking, because this is healthcare, is very accuracy first, security first. So what you're seeing here is there's a medical record that's already uploaded. The user here in the demo is uploading a denial letter, And then this one is particularly focused on sepsis, so they're selecting the sepsis code that's relevant, and then here's the denial letter that they're uploading. And then the system itself is just going to go ahead and read through the denial letter, confirm that it's a DRG downgrade for sepsis, and then read through the medical record, pull out the right information, and then generate an appeal letter, which is here in a draft form. The user can then edit that appeal letter if they want. They can copy it straight into our core workflow system so that we can submit it to the payer. And then there's a number of other information. If you kind of look at some of the other prompts on the left-hand side there, investigation, summary, denial information, check our work, all of that shows the actual kind of reasoning that the pipeline behind the scenes went through to pull out that detailed level information and then summarize it in that letter. So again, this is something, so these are the sepsis 2 and 2.5 guidelines that the models are comparing against and determining whether it meets the criteria or not. This is all happening behind the scenes in a relatively complicated, back to that earlier diagram, set of models. There are over 100 calls to different models kind of behind the scenes for each of these letters. You see these are all the kind of questions that are being asked to kind of pull out the right specific information to then summarize in that appeal letter. And again, the user can go to these and find the specific place in the medical record that it's cited. So there's no hallucinations, there's no kind of making things up. And part of, I said earlier, we started with DRG downgrades, and specifically with sepsis, and then we're expanding to the broader set of all DRGs. But the reason for doing that is very specific and deliberate, and again, it comes back to quality, right? This is not hey, we're gonna just throw a bunch of stuff at the wall and see what sticks. It's, hey, for very specific use cases, for DRG downgrades with sepsis, what is the pipeline we need to build that works and makes this accurate? We did a blind test where we looked at what the kind of AI pipeline produced versus what our experts had produced in the past for successful appeal letters. And we found, using a rubric that incorporated a number of different elements, style, argument, logic, guidelines, all those things, the AI actually slightly beat the humans in terms of overall quality of letters. So still a human in the loop process for us. We have our attorneys and our nurses and our coders who, as they get these accounts, they run it through this tool, they read the output, validate that it's correct, then we send it out, and starting with DRG downgrades with sepsis, expanding to other DRG downgrades, then expanding to broader medical necessity, length of stay, level of care type of denials, and then on from there. So this has been in some ways the culmination of a lot of our work over the past year and a half, but in other ways just the very beginning of our broader journey here.
Yeah, it's been fascinating to see this team take this problem and understand it, and then look at, again, the machine is just extending what the humans do today. They have rule books and sets of guidelines. They've got some evidence in this denial letter form. They've got to download this large, medical record, and we're talking the raw clinical documentation is what we're pulling down. And then this thing is doing what the human would do, but in a more comprehensive way of reviewing it against, I need to find evidence of this. Can I find it? If so, tag it and make it and show. And then importantly, as they talk about transparency, show the work. What was the very clear logic that it went through to make this argument that supports the argument in the appeals summary that we're writing? And that was what you saw down the left-hand side. It is a series of questions, but it's a series of evidence, and then it's a series of, I referenced this rule, and I'm trying to make sure it meets these things, and can I prove that it does? Which is the same thing that one of our humans does today, the attorneys specifically. And we don't use attorneys, I should have clarified, we don't use attorneys at Aspirion to go pursue legal action against a payer, albeit I bet some of the providers would be happy with that. We actually use attorneys because they're really good at saying, what's the law, what's the evidence, can I make a case against this law with this evidence? And so they're very adept at writing these legal arguments. But as Spencer pointed out, we blinded these 20 former successful cases and then ran it back through the machine, and then had the humans that are 5 of our best attorneys score these things blindly, and they scored that the machine did a better job quality-wise. It was like, holy cow, this is pretty impressive. And you guys probably won't be surprised, but one of the criteria where it clearly beat the humans was spelling and grammar. And I thought to myself, well, that's the U.S. education system. Has nothing to do with healthcare. But it was a really interesting exercise in terms of proving quality of this output. Like we can't do this just to do more volume. We need to do this, and it needs to maintain the level of quality and the overturn rates. And making the case in a compelling way, it has to meet the same quality or be better. And so we've been very focused on ensuring that is in fact the case. And again, taking this, case type by case type. But as you guys can appreciate, like creating code sets like that and building full libraries of codes and licensing, which is no short undertaking to go get Optum to license a number of code sets that we have to structure in databases kind of thing. It takes a lot of work. So building all those pieces and parts and the scaffolding to, put the recipe together is a lot of work. But as we've noted, there's benefit in doing that and releasing those tools to the end users just to make their job faster, to make them more efficient in the manual process that they do, noting that then once you connect the things together, it can begin to automate. And for us, it's not about automating these super high dollar complex cases, anytime soon. The humans are gonna have to do that. There's a lot of interpretation still, there's variations, there's edge case, different exception types, but the lower dollar, higher volume cases that we're seeing around these downgrades and types like that, again, we can't do it by throwing humans at it and get a good outcome, right? It's just not feasible, and we're leaking revenue, kind of month over month, year over year with these new rule sets. So.
And that's what a lot of our clients the feedback has been, is that many of them are not touching their DRG downgrades, or at least not the vast majority of them. So for a lot of them, for us, it's, hey, we have a new solution using the combination of our expertise and this technology, and then we can help, actually get through that kind of long tail that today is minimally, if at all, touched, which is a big part of the earlier point around we feel it's incumbent on us to invest in this so that we can, help our clients do better.
Yeah, that's the important part. It's really with this new trend and these lower dollar, higher volume partial denials. We already knew 60 Change Healthcare Optum Denial Index put this out. It's probably not been refreshed since the incident, but nonetheless, 60% of denials across the United States aren't worked, right? So there is a huge amount of inventory that goes untouched, and for many providers, they just accept the downgrade, right? I'm fine. All right, I billed you 10, you paid me 8. 8's better than 0. I'm not going to go chase the 2, but that's problematic, right? As we're talking about razor thin margins anyway, you can't allow that leakage to continue to happen. Then you combine that with shift in Medicare enrollment into Medicare Advantage, and those same rules being applied in a bigger population, having that same issue, with the technology that they've got in the commercial plans, and all of a sudden the problem got way bigger. So again, we are paid on a contingency basis, we are paid for an outcome, but we also recognize that there is this huge universe of unaddressed inventory and revenue that is owed clearly to providers that is not being captured, and we've got to apply technology to do it. We cannot just throw more bodies at it. We don't have the bodies, and 2, just economically, it doesn't make any sense. So again, our journey has been build these blocks, test these things, identify these cases, put the pieces together, then ultimately connect them with a dedicated team. We've got the benefit of having that has grown, as I mentioned, a lot. Hit a platform they had already built over 5 years, which is awesome. Now putting all those ingredients together and again, sharing that information with you guys so we can just again, lessons learned, what we've seen, that kind of thing is what we're here to do. So that's it. From us, happy to take questions from any of you guys.
And let me make one more point, which is I think a lot of people hear AI and think, well, is AI real? Is this just going to be another blockchain kind of thing that didn't go anywhere? I think the reality is we already live in an AI-enabled world. Everything from the ads you see to the apps on your phone to the way that you get to work on Google Maps, all of that is AI and machine learning. So it's already here, and we're just applying it now in this space and trying to transform some of the dynamics here with it, which is what personally excites me about what we're doing.